What if I told you that everything around you, your job, your city, your schedule, even the air you breathe, can be traced back to a single turning point in the 1700s? For thousands of years, humanity moved at the speed of muscle and wind. Then suddenly, the world accelerated. Not gradually, not gently, but irreversibly. Before we dive into the moment that changed everything, subscribe and like this video. If you're fascinated by the forces that shaped the modern world, the inventions, the risks, the unintended consequences, you're going to want to stay until the end. Because the Industrial Revolution wasn't just about machines. It was about redefining what it meant to live and work. Now tell me in the comments, do you think the Industrial Revolution made human life better, or simply more complicated? I'm curious where you stand before we step into the smoke of the 1700s. For 10,000 years, human life marched to the rhythm of the sun and the seasons. Men and women rose with daylight, fed oxen and mended sails, and the speed of production was set by muscle, wind, and the slow, patient turning of water wheels. Then, in the 1700s, a different kind of energy entered history. Not the slow, renewable rhythm of wind and water, but the concentrated subterranean power of coal. That coal spark, literal and metaphorical, helped rewire economies, reshape landscapes, and change how people lived and worked. I am Tim, and this is the story of the Industrial Revolution in the 1700s. How a handful of conditions and a sequence of machines set off a transformation that is still with us today. To understand why the revolution began where it did, imagine Britain as a place where several separate problems and opportunities met. First, agriculture had been changing for decades. Better crop rotations, selective breeding, and the enclosure of common land increased yields and shifted labor out of the fields. That meant more people could move to towns and work in new enterprises. Second, Britain's political and legal environment, relatively stable monarchy, growing protection for property and credit markets, made it easier for entrepreneurs to invest and to protect their inventions. Third, geography mattered. An island with many navigable rivers and a long coastline made domestic and overseas trade simpler. Fourth, the scientific revolution and Enlightenment cultures fostered an appetite for experimentation. Simple machines were improved, designs circulated, and artisans and gentlemen experimented side by side. Finally, there was an economic pivot that historians call wage-energy economics. Labor in Britain was comparatively expensive, and coal, abundant and relatively cheap in many regions, offered a substitute source of power. Put together these 5 pillars, agriculture, institutions, geography, scientific culture, and the economics of energy, created fertile ground for mechanized change. The first great theater of industrial transformation was the textile industry. Cloth had long been among the most valuable manufactured goods, and demand for cotton fabrics surged in the 18th century, driven by fashion at home and colonies abroad. The sequence of textile inventions provides a clear window into how technology, capital, and social organization interacted. In the 1730s, John Kay introduced the flying shuttle, a simple but revolutionary addition to the loom that allowed a single weaver to throw the shuttle across the warp much faster. That jump in loom productivity suddenly exposed a new bottleneck: spinning. There simply weren't enough yarn spinners to keep looms supplied. James Hargreaves's spinning jenny, developed around the 1760s, responded to that problem. The jenny allowed a single worker to spin multiple spindles at once. A useful device, but still primarily a hand-powered small-scale machine. It increased yarn output, but often produced a weaker thread more suited to coarse cloth. The next leap was the water frame, associated with Richard Arkwright in the early 1770s. The water frame used water power to drive rollers that stretched and twisted fibers into stronger, finer yarn. That machine required a sturdier site near a river and concentrated production in larger workshops. Then Samuel Crompton combined the strengths of the jenny and the water frame in the spinning mule, producing yarn both fine and strong enough for high-quality cotton cloth. Each machine solved a technical problem, and each pushed production into larger, more centralized settings. The domestic, cottage-based system of spinners and weavers gave way to the factory. Towns like Manchester, once a market town, grew into centers of mills and workshops. A Manchester street on an early industrial morning might be a chorus of clattering looms, men hauling coal, and children threading bobbins. Those machines needed power, and the story of power in the 1700s centers on the steam engine. Early industrial sites often clustered where rivers could turn water wheels. Water set the rhythm of manufacture. But water power had limits. It depended on geography and weather, and constrained where factories could be located. Mines, meanwhile, had a desperate practical problem: flooding. Thomas Newcomen's early atmospheric engine, developed in the first decades of the 18th century, was essentially a pump. It breathed new life into deep mining by expelling water and making deeper extraction of coal and tin possible. Newcomen's engine was heavy, inefficient, and costly to run, but it proved the concept. The critical breakthrough came with James Watt in the 1760s and 70s. Watt devised a separate condenser and other refinements that made steam engines far more efficient. A condenser is the part that cools and condenses steam back into water, allowing the engine to avoid reheating the main cylinder each cycle. Watt's business partner, Matthew Boulton, commercialized the engines and helped place them in mills, ironworks, and workshops. Steam power decoupled industry from riverbanks. Factories could now sit near coal fields, towns, or ports, and their scale could grow well beyond what water power previously allowed. The pairing of Watt's engineering and Boulton's production and sales made steam a practical engine for grinding, spinning, pumping, and eventually hauling. Iron and the means to make it stronger were the next building blocks. For centuries, iron production had relied on charcoal as fuel, but that resource was limited by the supply of wood. In the early 1700s, innovators like Abraham Darby experimented with smelting iron using coke, a processed form of coal, which burned hotter and allowed larger blast furnaces. Coke smelted iron made it economically feasible to build bigger machinery, stronger tools, and crucially, rails and structural members. The Iron Bridge at Coalbrookdale, completed in 1779, became a symbol of what iron made possible: structural forms and permanent works that timber could not match. Iron rails and plateways would later carry wagons and, after further improvements, steam locomotives. The use of coke did not just produce more iron, it created a feedback loop. Coal made iron cheaper, iron made machinery cheaper, and machinery made more intensive use of energy. Transport was the next arena of rapid change. Moving bulky, heavy goods, coal, iron, cloth, was expensive and slow on the rough roads of the era. Investors and engineers turned to canals as a solution. The Bridgewater Canal, opened in 1761 to serve the coalfields of Worsley and the mills of Manchester, is a classic example. By providing a smooth, low-friction water route, it dramatically lowered the price of coal entering Manchester and cut transportation costs for other goods. Cheaper coal meant cheaper heat and power, and the economic geography of industry shifted. Canals were followed by railways and steam locomotion in the early 19th century. The development of reliable rails and locomotives multiplied the speed and volume of movement. Pioneers such as Richard Trevithick experimented with steam locomotives at the turn of the century, and engineers like George Stephenson later refined locomotive design and railway systems, producing lines such as the Liverpool-Manchester connection that opened in 1830. Steamships, too, began to shrink the world. They made river navigation predictable and eventually transformed ocean travel and global trade. Each improvement in transport shortened effective distances, lowered costs, and integrated local markets into national and international networks. But these machines and networks carried a human cost. Urbanization accelerated as people left agricultural labor for factory jobs. Towns that had been modest market centers ballooned into manufacturing cities with dense housing, few sanitation systems, and polluted air and water. Imagine a foggy morning in an industrial town, chimneys belching smoke, streets choked with soot, rivers darkened by tannery and mill runoff. The public health consequences were severe. Outbreaks of cholera and other epidemics were common in crowded, unsanitary neighborhoods. Housing was often squalid, narrow courts and back-to-back houses where entire families lived in a single room. Inside factories, discipline changed daily life. Time became regimented by the clock. The factory owner's whistle and the clatter of machines set the day, unlike the staggered rhythms of agrarian life. Working hours were long, often 12 to 16 hours a day, and conditions could be dangerous. Children were part of the workforce. They crawled beneath looms to untangle threads, worked as piecers to repair broken yarn, and hauled coal in cramped mines. Accounts from the period are grim: dust, deafening noise, and machinery without safety guards. The moral response was complicated. Some saw the mills as engines of progress and rising material standards. Others, from radicals to social critics like Friedrich Engels, documented and condemned the human suffering. Mass movements emerged. Machine-breaking Luddites protested job displacement and wage pressures. Factory reformers campaigned for limitations on child labor, and workers began to organize into trade unions to press for better wages and hours. The legal and institutional response evolved slowly. Early factory legislation in Britain, piecemeal measures in the early 19th century, began to limit the worst excesses. For example, restricting child labor and regulating working hours. Trade unions, initially illegal or semi-legal, gradually gained legitimacy and bargaining power over the course of the century. These social and legal adjustments were responses to real suffering, but they were also responses to a new economic reality. Industrial capitalism produced great wealth for some, while pushing others into insecurity. To see how the Industrial Revolution spread beyond Britain, it helps to remember that the revolution was not a single invention, but a constellation of changes: machines, fuels, transport, finance, and institutional practices. Belgium industrialized early in continental Europe because it combined rich coal deposits with entrepreneurs and engineers who copied British machinery. In parts of France, a combination of artisanal traditions and political upheaval produced a different pace. Mechanical factories developed alongside traditional craft production. German states, fragmented politically, invested heavily in railways and later in chemical and steel industries. By the mid-19th century, Prussian rail networks were key to industrial growth. In the United States, abundant natural resources, a huge domestic market, and innovations such as the American system of manufacturing, standardized, interchangeable parts, drove a distinct path of industrialization, one that favored mass production, scale, and internal markets. Japan's Meiji leaders in the late 19th century actively imported machinery, engineers, and institutional models to accelerate industrialization on a state-guided timetable. Each country adapted industrial techniques to local resources, institutions, and markets. Diffusion was neither instant nor uniform. By the second half of the 19th century, a new phase, often called the Second Industrial Revolution, added steel production, electrical power, and new chemical processes to the economy.
Henry Bessemer's process for making steel cheaply, mid-1850s, transformed construction, railways and machinery. Steel rails replaced iron rails, and skyscraper frames became possible. Electricity emerged as an even more flexible form of power than steam, eventually enabling factories to arrange machinery in new ways and to bring light into workplaces and homes. Petroleum, internal combustion engines, and chemical industries rewired transport and consumer goods.
But these later developments build on roots planted in the 1700s. The move away from muscle and wind towards fossil fuels, the centrality of mechanization, and the shift toward factory-based production. Throughout these developments, gains and harms coexisted. Industrialization delivered dramatic increases in productivity. More goods could be produced more cheaply. Standards of living for many rose over decades, and new consumer goods spread through societies. Cities became engines of cultural and intellectual life. New professional and managerial classes emerged alongside industrial capitalists. Yet the costs were real and long-lasting. Polluted rivers and soils, urban overcrowding, hazardous workplaces, and social dislocation. The environmental legacy, coal smoke and soot, deforestation around charcoal-dependent ironworks, and later fossil fuel-driven greenhouse effects, began in this era. The social legacy included both the expansion of mass wage labor and the political responses it generated, trade unions, social reform movements, and eventually social legislation. It is important to avoid simple stories of inevitability. The Industrial Revolution did not happen because of a single genius or a single invention. It emerged from a particular mix of resources, institutions, and cultural habits. If Britain could have been the birthplace of industrialization, it was because agriculture, law, coal, geography, and a culture of practical experimentation happened to line up there at that time, and because inventors and entrepreneurs seized the opportunity. At the same time, contingency mattered. Mines flooded, markets shifted, and patent disputes or local resistance sometimes slowed diffusion. Technology created possibilities. People and institutions decided how to use them. To bring this down to a human scale, picture a child in an 18th century mill. She climbs steps into a dim room where spindles hum and the air is full of lint. She spends 12 hours tending machines far from the fields her grandparents worked. Some families found regular wages preferable to uncertain harvests. Others felt dispossessed by mechanized competition. The factory clock replaced sunlight as the regulator of life. Outside, a canal boat glides past, carrying coal that will keep the mill running for another day. The canal and the mill are connected. Cheap coal, a steam engine, an ironworks, a loom, each part of a chain that reshaped the landscape and social order. Numbers can help convey scale without turning into dogma. Cotton imports into Britain rose dramatically through the late 18th and early 19th centuries, moving from the low millions of pounds of raw cotton annually in the mid-1700s to many times that by mid-century, reflecting both colonial trade and mechanized demand. Cities swelled. Manchester and other textile towns moved from market town populations into tens or hundreds of thousands over the next several decades. These are not mere curiosities. They signal how fast and how far economic life could change once factory production, steam power, and cheaper transport were combined. Critics like Engels and thinkers such as Karl Marx responded to these transformations by pointing out the uneven distribution of industrial wealth and the alienation of labor under wage systems. Others celebrated industrialization's ability to lower the cost of clothing, improve transport, and diffuse new goods. Both perspectives capture part of the truth. The Industrial Revolution created unprecedented material abundance for many, but also entrenched inequalities and new forms of precarity for others. The environmental consequences were immediate. Blackened skies and fouled rivers, and they set a pattern of extractive, fossil fuel-dependent development that would become globally dominant. What lessons does the 1700s offer to us now? First, that energy is central to economic change. The switch from muscle and water to coal was not incidental. It was transformative. Second, that institutions, geography, and culture matter as much as technology. Inventions need markets, capital, legal protection, and human skills to scale. Third, that technology is morally ambiguous. It can liberate and brutalize, create prosperity, and deepen inequality. Finally, that social and political responses Laws, unions, public health measures are not afterthoughts, but part of how societies adapt to technological shocks. The coal spark lit a fuse in the 1700s whose fire illuminates the modern world. The mills and mines of that century created the frame for later innovations in steel, electricity, and chemicals. They also seeded debates about labor rights, public health, and environmental limits that continue today. If you want a full walkthrough of the machines, the inventors, and the social history that followed from the spinning mule to the steam engine to the iron bridge, subscribe and follow along with the rest of this series. There's a lot more to unpack. As the story closes, consider this image. A factory clock. Its hands moving steadily, calling men and women to work. That clock is at once progress and constraint. It symbolizes punctuality, productivity, and the modern discipline of timekeeping, and it also marks the moment when daily life increasingly conformed to the demands of machines and markets. The Industrial Revolution in the 1700s built that clock and set it ticking. Its echoes reach us still, in the cities we live in, the goods we wear, the transport networks we use, and the environmental challenges we face. If this account sparked your curiosity, share it with someone who loves history, and check the links and episodes for deeper dives into specific inventions, places, and people, because the story of the 1700s is not only about machines and materials. It's about how ordinary lives were rearranged by a centuries-long experiment in harnessing new energy and organizing labor in new ways. Thank you for listening. Until the next episode, I'm Tim.